Okay, these notes are for the limits involved in infinity. The first ones we're going to do are talking about infinite limits. So in Algebra 2, you heard about if a function increases, so f of x increases without bound. F of x is approaching infinity. If f of x decreases without bound, f of x approaches negative infinity. And we're talking about some arbitrary value c along the x-axis. So on these cases here, the first example right here, when we're looking at this first graph, it looks like a rational function of some sort where this is decreasing from the left and it's decreasing from the right. So the limit as x approaches c of this function is going to equal negative infinity. And this would be the value c right here. So I could say the limit as x approaches c from the left of f of x is going to be the same as the limit as x approaches c from the right of f of x. For the second graph, I've got the limit, this function is still a rational function, but this is going down forever, and on this side it's going right forever. So we say the limit as x approaches c of f of x does not exist. It fails to exist. The limit as x approaches c from the left of f of x is going to equal negative infinity, and the limit as x approaches c from the right of f of x is going to be positive infinity. The third example is very much like the second example. From the left, the function is approaching infinity. From the right, the function is approaching negative infinity. So the limit as x approaches c of this function does not exist. And the fourth one is very much like the first one. But what's happening is the left-hand side is going up forever, the right-hand side is going up forever. So what we say is the limit as x approaches c of f of x is going to equal infinity. So in a nutshell, the limits involved in infinity, these infinite limits, are really looking at vertical asymptotes. Every single one of these values occurred with a vertical asymptote. So when we actually look at problems, and here's examples now, I have this first example, f of x equals x plus 3 divided by x minus 1. If you remember from Algebra 2, there's a vertical asymptote at x equals 1. And when you get better at this, you should start to recognize what happens if I go to the right of 1 and I go to the left of 1. But let's look at it in numerical. So let's look at a table of values first. And you can do it in a calculator. I would recommend you do it in a calculator. So we want to look at the numbers as you get close to 1 from the left-hand side. So I'm going to choose 0.9, 0.99, 0.999. And if I put a 1 in there, I know I cannot get a value. There's a vertical asymptote. Then I could choose to the left. So I'd have 1.001, 1.01, and 1.1. And I've already put these in my calculator and gotten values for these. So I get negative 39, negative 399, and negative 3,999. So if I look for the limit as x approaches 1 from the left of f of x, my numbers as I get closer and closer to 1 coming from the left-hand side are getting more and more negative. So this is going to equal negative infinity. As I choose numbers from the right, so this would have gotten me 41, 401, 4,001. So the limit as x approaches 1 from the right of f of x, these numbers keep getting larger and larger. So this is approaching infinity. So the limit fails to exist. We're just talking about behaviors. So the limit as x approaches 1 of this function, x plus 3 over x minus 1, does not exist. And if you just want to do it numerically without a calculator, you can look at this and say, okay, if I pick a number that's greater than 1, that'd be to the right of 1. So if I pick a 2, I'd have 2 plus 3 over 2 minus 1, which is 5. That's a positive number. I know I'm going towards positive infinity. If I pick a number left of 1, say I pick 0. 0 plus 3, 0 minus 1 gives me negative 3. That's a negative number. I'm going towards negative infinity. So the next one I'm going to pick is this x squared minus 4 over x plus 2. This one, if you remember from Algebra 2, it does not have a vertical asymptote. If I were to look at this closer and factor the numerator, the factor is the same in the numerator and the denominator. So this is going to be equivalent to x minus 2, which is a line. But this is not a line. This has got a hole at x equals negative 2. So let's look at what happens here. So I have x and g of x. And the numbers I'm going to pick left of negative 2. So negative 2.1, negative 2.01, negative 2.001. I know at negative 2, I can't get that value. Right of negative 2, I'd have negative 1.999, negative 1.99, and negative 1.9. So if I go left of negative 2, the values I get are negative 4.01. Oops, sorry, I looked at the wrong one. It's negative 4.1, negative 4.01, and negative 4.001. So the limit as x approaches negative 2 from the left of this x squared minus 4 over x plus 2 is going to equal negative 4. If I look at values from the right, I fill these in already. I've got negative 3.999, negative 3.99, and negative 3.9. So the limit as x approaches negative 2 from the right of x squared minus 4 over x plus 2 also is negative 4. So that means the limit exists because the limit from the left and the limit from the right are both the same thing. So infinite limits have to deal with vertical asymptotes. The other type of infinite limits, we're talking about limits involving infinity. We start looking at the limit as x approaches infinity or as x approaches negative infinity. So this graph would show me an example of that. The limit as x approaches infinity of this function, 2 plus 1 over x, is what's happening at the far ends to the right of here. So you can barely see it. The y value that this gets closer and closer to is 2. If I looked at this, the limit as x approaches negative infinity, what I'm looking at is what's happening as this goes further and further to the left. Not exactly what's happening right here, but as I go farther and farther away. This ends up also being 2. So what we're looking at is a horizontal asymptotes. Horizontal asymptotes is what the function approaches at the far ends. And these can be done numerically as well. So if I look at this first one, if I have x and f of x, and I want to start with a small number and get larger. And it doesn't matter which ones you've chosen. So if I put a 10 in, I get 2. If I get 100, I get 2.86, 2.98, and 2.99. So what's happening, the limit as x gets larger and larger, so as it approaches infinity of 3x minus 2 over x plus 4 is going to equal 3. If I look at what's happening towards negative infinity, so here I've got f of x, or x and f of x. So we get negative 10, negative 100, negative 1,000, and I could keep going. I'm just going to stop here because you get to see the idea. At negative 10, I get 5.3. Then I get negative, or positive 3.14, 3.01, and 3.00. So once again, as I get closer and closer to negative infinity, the larger and larger the x value gets, the closer and closer I get to 3. So the limit as x approaches negative infinity, 3x minus 2 over x plus 4 is going to equal 3. And I could go out more decimal places. This is not going to be exactly 3. I could go out quite a ways, and I'm just going to start getting different numbers. So what happens now with this next equation? Oh, also, before I go on, let me go back to this. The 3x plus 2 over x, if you remember from Algebra 2, the degree in the numerator and the degree in the denominator are both the same. So my horizontal asymptote is going to be a ratio of the leading coefficients, y equals 3. That's where these come from. So the next one that I've got, if you remember your horizontal asymptote rules, or you might need to look them up to refresh your memory, the degree in the numerator is a 1, the degree in the denominator is a 2. So my horizontal asymptote is going to be y equals 0. So when I do this, my horizontal asymptote is y equals 0. That's what my limit should be. So if I looked at x and g of x, and I'm just going to use the same numbers again, 10, 100, 1,000, 10,000. I get 0.27, 0.03, 0.003, and this one on the calculator gave me 3e negative 4. You have to understand that this is saying 3 times 10 to the negative 4th, which means I need to take the decimal place here and move it back 4 spots. There's my new decimal place, fill in with zeros. So this is 0.0003. And if I go out to 100,000, this is going to get smaller yet. So the limit as x approaches infinity of 3x minus 2 over x squared plus 4 is going to equal 0. And I can do the same thing, check for negative infinity. So I'm going to do negative 10, negative 100, negative 1,000, and negative 10,000. The numbers I get, negative 0.31, negative 0.30, negative 0.003, and negative 3e at the negative 4, which we just talked about, so it's going to be negative 0.1230 zeros and a 3. So the limit as x approaches negative infinity of this function is x squared plus over x squared plus 4 is equal to 0. And it doesn't have to be the same, infinity and negative infinity. Some functions actually have more than one horizontal asymptote. So it can be a different answer from going towards infinity and going towards negative infinity.